We have point B there. We have point D somewhere here. We have point C, where there is obviously the initial point. And we also happen to have so this is our initial point, H, A, B, and then C. So the whole idea here is we have the IC curve of the individual looking like this, the indifference curve. We have the budget constraint. We now understand why this guy is a king from our last meeting. Now there's a need for us to take it a step further. And by step further, I mean factors that might come in and affect the person's behavior. So let's take the situation where, if you quite remember correctly from our last meeting, the consumption of the individual looks like the C plus WL equals, I believe WH plus pi minus T. So this is what we had from the last time. So with this diagram, what I'm trying to do here is I'm trying to see what will be the effect of the individual's behavior when this guy here changes. So that will be the first part of today's discussion. So let's put this guy here, the first part. So this will be the first part of today's discussion. What happens with this diagram and the behavior of the individual when the next non-wage income changes. So for the sake of your understanding, this guy here is what we call the non-wage income. You don't necessarily have to work to earn this. Basically, the profit that you get is from your investment. So when you invest in a company, they will just give you the dividend and the government will take away the taxes from you. So you don't work to get it. So that's why it is called the non-wage income. So what Williamson tries to do here is to see the effect of the non-wage income on the individual's action. And that's what I'm about doing. So when the non-wage income increases, when this guy here increases, what happens to this diagram? When the non-wage income increases, what happens to this diagram? So let me know if you have any question on this setup. The second setup I will be looking at will be coming from the wage income. And that will be somewhere around this side by looking at the wage. So that will be the second discussion. This is the wage income. Now the question here is, what happens to the individual's action when the wage increases? This is the wage income, this is the non-wage income. The two will have different reactions and different connotations. So you have to keep that in mind. So let me quickly start by looking at the non-wage income. Then we'll come back and look at the wage income and we'll just continue with the quiz. So let me just draw what we have by way of Williamson. When this guy is to increase, a couple of things do happen. First of all, you have an increment in terms of.
We have a question.
Yeah, sure.
Will the wage income be wage times like 24 hours minus L?
Yeah,
like,
yeah. Sure, that's true. I'll come back to that. Yeah, so basically what you're looking at is you're looking at W multiplied by the total amount of hours that you have minus the leisure. So this will be the non-wage income, right? And this is just the wage. The reason why I tried to place this guy here is I wanted to remind you guys of what the previous equation was. So ideally, as you guys rightly pointed out, I should have moved the WL to this side, break it down to this side before calling it as the wage income. Yeah, so you guys are right. So that's why I don't want to rush into that for now. I'll come back and look at that. Is that okay?
Yeah, that's good.
Good. So let me try and start by looking at it. Oh, sorry, my Zoom here is not working properly. So let's try by looking at the diagram that Williamson provided with us. So we had the J point here. We have F somewhere up here. And yeah, so this becomes a new point because your initial point no more becomes the point of consumption. So I'm going to draw this guy here to represent the new increment in your available non-wage income. So given that your non-wage has increased, the budget constraint is to move up because you can now afford more. That will be the first part of the discussion. Now, within this diagram, as you guys might have recalled from our last meeting, we have to take into account the fact that with a higher budget constraint comes a higher indifference curve because you can now afford more. So this becomes my new indifference curve, which I call the indifference curve 2. So we have indifference curve 1, which was the initial point where there weren't any increase in non-wage income. And we have indifference curve 2, which now captures the fact that your non-wage has increased, so your point of consumption or your optimum consumption point should have to increase. So this is where Williamson places K. So if this guy initially at the point H, your consumption bundle was such that you preferred L1 star and maybe somewhere C1 star. So at this point initially, point 1 or point H, your optimum bundle happens to be C1 star and L1 star. With an increase in your non-wage, let's see what happens to you. You realize that your leisure will have to increase to L2 star, and your consumption will also have to increase to C2 star. So with points K, we now have C2 star, which is an increment, and we have L2 star, which is an increment as well. So your consumption increases and your leisure increases whenever, again, just to point it out, your non-wage income increases. Is there any question, Ella?
No.
Good. So if anyone is to have any question with this, please draw my attention. Let me know if I can help with that. My Zoom just went out. Let me try and connect it again with yeah. So this is what I would like you guys to pay attention to with the non-wage income. So please let me know if there's any question. All good? All good? Ella? Good.
Yep.
Now let's go to the wage income. And this is where we have to really pay attention. This is where the difficulty might be coming from. And this is where we need to motivate everything that we do today from. Whenever you have the wage income increasing. So let me try and put it into context. What this new chapter is going to do. This new idea we have here. So remember that an individual has a decision to make. To recall, we have C equals W H minus L plus pi minus T. With this budget constraint, an individual is expected to make a decision. When the decision has to do with his wage income there are two things that play a role. First, we have what we call the income effect, and then we have what we call the substitution effect. The income effect is such that when we assume that there is an increase in his wage income, you are much richer. So you have higher income. And given that fact, the whole idea here is that you now feel richer and you don't want to work as hard as you used to. So the number of hours that you want to work, which is the NS that we saw earlier, tends to reduce. That's the first part. When I worked for Tim Hortons and I used to be paid $10 a day, the next morning I went there, they said my wage has increased to $20. I now feel richer and I don't want to take all the extra hours that I've been taking because I used to be poor. That's why I took those extra overtimes. Now I'm richer, so I don't want to work as hard as I used to. So your number of labor supply, which is the hours that you work, tends to reduce whenever your income effect comes into play, given the fact that your wage income has gone up. On the other side of it, with an increase in the wage, there is what we call the substitution effect. And substitution effect basically says that, hey, now instead of working or having leisure, for every hour that I spent sleeping, I could have gained $20 with this wage increment. So you tend to be thinking about it along those lines and go like, hey, I don't want to be sleeping the whole day, given the fact that the wage has increased and I could have earned more by working. So what the substitution effect does is, it tends to take away the fact that you don't want to be lazy anymore and you want to work more hours. So here, the number of labor supply that you tend to give goes up. So these are the two opposing effects. One of them tends to reduce your hours of work, while the other tends to increase your hours of work. Put in another way, if you want to represent it in terms of leisure, here your leisure hours goes up, whilst here your leisure hours come down. Questions? Questions? Good. So this will be the first part of the wage income effect.
I have a question. Sorry.
Oh, yeah.
For the substitution effect, the two goods are consumption and, is that an L? Consumption and leisure, or is it hours of work and leisure?
Let's look at hours of work for now. I'm just going to tackle consumption. Consumption has one direction. It's mostly the fact that with an increase in wage income, there is a direct effect on your consumption, right? So with consumption, this guy here, there is no ambiguity. Whenever your non-wage income increases, it increases as well. But what we don't know is this guy, because this guy plus this guy is unknown. So for your bundle, your final bundle, we know C goes up, but leisure, we don't know. Is that clear?
I think so.
Okay, good. So this is what we mean by substitution effect and income effect. In the situation where the income effect is higher than the substitution effect, for sure, we will then see that the leisure will go up. When this guy is greater than this guy, the leisure goes up. And the opposite will be the case when this guy is greater than, when the substitution effect is greater than the income effect, the leisure goes down. And we mostly look at the point where your leisure goes down because substitution effect is higher. So that's the whole intuition behind this. So one thing I would like you guys to pay attention to is, how do I tackle this, the non-wage income? How do I tackle the wage income? How do I understand the income effect? How do I understand the substitution effect on the hours of work or on the leisure? And how do I also understand it in terms of the increases in consumption? If you're able to understand that, then you are fine. So let's try and see how we can draw this on a diagram and make sense of it. So just alert me whenever there is a question in the chat room, Ella.
Okay, sounds good.
So before we go ahead, this will be your quiz quid, the quiz code for today, K1W1, all caps. This will be your quiz code for today, K1W1, all caps. All good? Okay. K1W1, all caps, that will be your quiz code for today. When you go to Canvas and they ask you of it, just place it there. Let's go ahead and see how Williamson drew this on his diagram. And this might be a bit tough to understand, but just bear with me on that. So
Are we doing the quiz? Are we doing the quiz now, or are we? That's just the code for later.
Post it when the time is due, but when you get to Canvas, when the time is due, just write this quiz code there.
Okay.
So this is in line with what we discussed on the first day. I pointed out the fact that all the quiz questions will be posted during lectures, and that's by way of providing you guys with the code, right?
So it's still in class though?
Yeah, it's supposed to be in class. So it's just going to be in a box, I believe, very soon. Yeah.
Okay, sounds good.
I've not yet published the questions, so I'm very sure you guys cannot see it, right? Yeah, it can't be accessed for now. So let's try and just go ahead and understand the income effect and substitution effect on a diagram. If anyone is able to access it now, let me know. But for now, I know I've already logged the quiz questions, and I can only make it available when I click on the publish. That's what they tell me. So I'll come and publish it very soon.
That's right. We can't do it.
We have the income effect and substitution effect, and we'd like to see it on a diagram. So let's try and draw this guy here and see how we can understand this on a diagram. So I'll still go with what Williamson provided. I still have point D somewhere here. This is the maximum that you can get in terms of your hours of leisure. I have the initial point B somewhere here. I have point A somewhere here. And yeah, so point A and B will join each other here. Then I move on to which points again? I believe it's gonna be, yeah, point E to B. Point E to B, which is somewhere here. Point E to B. Point E to B, which is here. After point E to B, I know that there is already the initial point on the indifference curve. So the first indifference curve will look like this. And that will be point F, somewhere here. So point F is here, which is the initial point. It goes in line with consumption 1 and leisure 1. If it is not clear, let me know. I'll work on it. If it's clear, then that'll be good as well. After drawing these points, and I have point H. Point H will be the second indifference curve, which is somewhere here. So here is point H. I believe so. Yeah, point H, I think, is on the exact point as point F. This is point H as well. And I have C2 somewhere here. Okay, so we have C2 somewhere there. So this is my indifference curve 2, and this is my indifference curve 1. So the whole idea is all the black lines represent my initial point, my first point where I was before the wage increment. And the red line represents where I happen to be when the wage increased. So what you tend to see here is that before the wage increment, I consume C1 and C2, which is at the point F. So point F, I have C1 star, I have L1 star. This is basically my initial point. When the wage increased, which is my wage income, I move to an initial point, which we call point H. At that point, you see that you can clearly see that C2 has increased to C2 star, whilst L still remains L1. And that's where the confusion is, because with the L, we don't know whether the income effect is higher than the substitution effect, or the substitution effect is higher than the income effect, or they will tend to cancel out. We don't know for sure. Is that okay? So this will be the initial point. If you have any question for now, ask before I go to the difficult part.
No questions.
Good. Now let's go to the new part to understand whether the income effect will now play a role or the substitution effect will overtake the income effect. Let's see how that works. To understand that, there are two simple principles that I would urge you guys to hold. First, draw a line or a budget line that is parallel to the old indifference curve, to the old budget constraint. Draw a line that is parallel to the new budget constraint. So I'm going to draw a line that is parallel to this new budget constraint, which is the red line. At the same time, it is tangent to the old indifference curve. This line, first of all, will be parallel to the new indifference curve, to the new budget constraint, but parallel to the old indifference curve. If you're able to draw that line, then your work is done. If you're able to draw a line that is parallel, so I'm going to draw a line that looks parallel to this, and at the same time, tangent to this. So let's see how to draw that line. I think they played it somewhere here. So this blue line, as you can see, happens to be parallel to this old budget, to this new budget constraint. So my blue line is parallel as indicated. I have it. At the same time, it is tangent to the old indifference curve. To the old indifference curve. I have it. And that will be this point. And just label that point, I believe, point O. So this will be how we can go ahead and understand what substitution effect is and what an income effect is. Is there any question in the chat room? Ella?
No questions.
Okay. So we have this new point. This is point J to K. It happens to be parallel and it happens to be tangent. Now the question here is, how do I understand what an income effect is and what a substitution effect is? Remember, A substitution effect means that you don't want to sleep anymore. You want to substitute away from leisure to working harder. So when you look at this diagram, moving from point F to point O, moving from point F to point O, what do we see? We tend to see that your leisure reduces. And because your leisure has reduced, it implies that the number of hours that you tend to work increases. And whenever your number of hours increases, it means you substitute away from leisure to work. So substitution effect increases. That's the first part. So the movement from point F to point O on the same old indifference curve will give us a substitution effect. Questions?
Yeah. So can you explain again, Alex, is that the whole thing, or you want to clarify what you mean?
Which side? Is it the whole scenario again?
I didn't see when the message came in.
Giving the sorry, I couldn't hear you clearly. So you guys want to start all over again, right?
I'm not sure. Alex, do you want to clarify what you mean, or?
Yeah, Alex, come in. Hi, Alex.
Not getting the message.
Okay. Are we there? Is there anyone with a question?
There's nothing else.
Alex, if you don't mind, you can type it and I cut it again.
Okay, so we have another question.
Okay.
By when you said get the substitution effect, do you mean that we see that the substitution effect is larger than the income effect?
Oh, that's a good question. That's a good question.
Decrease.
Come to the income effect actually. So the first movement that we just did, which is moving from point O or point F to point O, represents the substitution effect. We'll have to come in again and do the same adjustment by using two different points to get us the income effect. And we will then see where the total effect will come in. Is that clear? So we are yet to come to the income effect.
Right, so it doesn't necessarily mean that the effect is larger than the income effect. It's just an effect either way.
Exactly, we don't know. Yeah.
Makes sense, thanks.
Good. So Alex, if you are still typing, let me know. Now the next point here that we need to understand is the movement from point O to point H. When we move from point O to point H, that's what gives us the income effect. So what you tend to see is that moving from O to F, we are now getting a much larger increase in leisure. So leisure tends to increase, and with an increase in leisure, the number of labor supply goes down, which then gives us this, the income effect. Right? So coming back to the earlier question that you guys asked, does that mean substitution effect is higher than income effect? It depends on the magnitude of the movement. How far did we move from F to O, and how far did we move from O to H? If moving from O to H is higher than moving from F to O, then we have income effect, net total income effect. If moving from F to O is higher than moving from O to H, then we have a net total of substitution effect. Is that clear?
Yes, that makes sense.
Okay, good.
Oh wait, we have a question. Does income effect here increase or decrease?
It increases, right? Remember, first of all, the whole idea here is that your wage, which is W, has increased. So whenever your wage increases, your income increases, right? So income effect for sure increases. And that's what we see on this diagram. They're moving from this point to this point with this increment. The basis of this question is that you have an increase in wage income. So income effect for sure increases. Yeah.
And secondly, why does moving from F to O, why is that substitution effect and not income effect? What is the rationale behind that? Why cannot O to H give us the substitution effect?
Yeah, that's a good question. I don't think I have much time to go through it, but the whole idea here is that given the fact that you are now maintaining the same budget, so this budget line, it is trying to maintain the same expenditure that you had earlier. So in the absence of your wage increment, point F and point O could be attained. So with this new line, I'm trying as much as possible to see what happens to the point where, regardless of this increment in wage, let's take away the fact that this wage has increased. Is there a point where I can still maintain the balance between the increments in wage and the consumption, such that with these new changes, I can still go back to where I was? Remember, this indifference curve is still on the same old one. It hasn't changed. You probably have to substitute away from having more leisure to maintain the same balance that you had earlier. So this is what they call the Hexian, and I don't want to go too much into it. So if you have to take 302, it has more of the intuition over there. But if you still want more of the intuition, I'm happy to take you guys through, probably during my office hours or whenever you guys have time. Osama, is that okay? We are just trying as much as possible to draw this line to see how best we can maintain the point that we used to be on.
She says it's good. And we have one last question, but aren't both consumption and leisure increasing when we move from O to H?
It's not as if I'm moving, yeah, so that's a good question. So here I'm moving, so the gap between moving from here to here, and when I move from here to here, what's the gap? So we are looking at this axis, right?
Yep.
Yeah, we are looking at this axis. You're not necessarily looking at this axis. Yeah.
Okay. Sounds good. That's good.
So if you have any question, let me know. So again, I've posted the quiz, how do you call it? I've posted the quiz code. I'm going to see whether I can publish it right away. So you guys should get yourself ready for the quiz. So get yourself ready for the quiz. It's going to take, I believe, 20 minutes. Any minutes that you spend above the set period will give you 0, 1.2 deduction. So I've posted it. Please let me know if you have any question. It's been posted.
Are we on break when the quiz is done?
Yeah, we're going to come back when the quiz is done. So I'm going to be here after 20. So please go to Canvas right away and start with the quiz. Let me know if you have any problems on Canvas. I've posted it. I'm going to be here. Just talk to me directly if you have any question.
Excuse me?
Yeah.
Hi, I seem to be putting in the code, but it doesn't appear to be working. It just brings me back to the submit page and nothing changes.
Oh, okay, let me see right away, please. And did anyone, is K1, W1, right?
K1?
Q, capital Q. And
Q1, W1?
Yeah.
Okay.
My code worked, so it should be.
Your code worked? Yeah, mine doesn't seem to.
Sure. So we have the code already here. Is it John?
Yes.
Sorry.
Yeah, it just doesn't let me in. It keeps throwing me back to the access code page and nothing changes.
Okay.
Is it case sensitive?
Yeah,
Ah, that might be why.
please all caps.
Ah, okay. There we go. Thank you.
Yeah, sure. So you guys have 20 minutes. 1 minute's gone, and I'll be here when you guys are done.
Hi there. For question one, I have the option for all of the above, but there's nothing above it.
Oh, really?
Yeah, like the option to press for multiple choice, all of the above is the first answer in a way, and then all the other options are below it. So when you do all of the above, which one are you
Oh, yeah, it means everything.
referring to?
Yeah, it means everything there. Sorry. I think it has to reshuffle them, right? Sorry. I think Canvas reshuffled it. So it means everything that you see below goes up there. So it will be all of the below. All good?
Hello. I just wanted to clarify the written question.
Yeah.
Yeah, it indicates that out of the 26 apples, he or she, is it regarding the apple producer?
Yeah. Yeah. Yeah.
Okay, thank you.
So you have a minute to stop. Whenever the time is due, please make sure you stop. If not, you will be deducted some points.
Is it only a minute? Mine says 3 minutes.
Yeah, it should be. Yeah, I gave you guys extra 1 or 2, so just.
So that's maybe about 7. We're just waiting for the next part. It is like the opposite of the map, right? No, you don't know. I was back. That's I am actually trying to get as effective as possible. We're young and healthy. I agree. My house. In my house. Like, you know, our neighbor. Yes. That's what it should say about it. Yes, but it is. And they where. You know, I mean, we've had this example one day. Horrible. Like, you know. But I have to say, I understand there was like, you know, we had our family back here. But if you're going over.
Is it okay? Have you guys been rolled out yet? Is it still active? Hi guys.
For the written question, do you guys have to review it and give the mark?
Yep.
Cool.
Are you guys signed out automatically or are you still writing? So that's the end of it. That's the end of the quiz. Yeah, so it's due. Okay, so if at this moment you are to write extra without submitting, then I believe I will take 1.5 marks for every minute spent. So I'll give you guys 2 minutes to relax and come back and join me after that. So just take 2 minutes off and come back and let's start with today's discussion. Your TA will come back to take the attendance for today, so make sure you are available. Ella, are you guys still writing? Hi, Ella.
Hi.
Are you guys still writing?
I don't think so,
Oh, okay.
but I can't say for everyone.
Oh, okay. Was the time okay? If you can ask them. Hi, guys. Was the time for everyone, or it was just too much of a rush?
If there's calculation question, I think it's a bit rush, but it will, I can complete it, but I can't like double check and make sure I get the right answer.
Well, is that the same experience as someone's in the
Yeah, I would agree with that. You can get it done, but you can't really check and make sure that your answers are correct.
Okay.
Maybe if the timer started when we start it ourselves, I think because you had a different timer, and so some of us started it a bit after you, so it was a little bit different.
Yeah,
Oh,
I
okay.
noticed when you said that there was 1 minute left, it was telling me I had 3 minutes left, so I was
Okay.
kind of confused.
Okay. Good. Good. I think these are all learning experiences. Hopefully we can modify it the next time we try the other quiz. Yeah, so for the quiz, what I try to do here is I try to reshuffle the questions, as you guys might have realized. And secondly, I thought, I don't know, maybe I might be wrong, I thought 5 multiple choice questions which aren't demanding, quite apart from one which has to do with the GDP value addition. My line of thinking is that you guys could have used 2 minutes or less for each of the multiple choice. So that brings it to 10 for the multiple choice. And for the written part of it, my line of thinking again was that because we've already seen the question per our lecture, because basically it's just the lecture question that I posted. And the only changes I made to it was to add both the investment and the export and import in it. So that was basically the whole idea. And if you guys could have practiced it, more, my thinking is that it could have taken 10 minutes or less to finish. But having said that, I'll probably have to consider the time in the next time round and see how it works. Okay. Is there what about the wording of the questions? Was it clear or was it confusing? Was something not so much? Questions? Ella, what are they saying? Is Ella there?
Yeah, I'm here. I don't think there's any questions. Oh, hang on. Will we lose marks if we didn't show all of our work? I was writing on paper and did not have enough time to type everything onto the box.
Oh, I'll see to that. I'll see to that. I thought, again, maybe my line of thinking was wrong. I thought because it was the expenditure approach, basically what you guys needed to do was to write a formula for the expenditure approach, which is the easiest, and say, hey, C equals this, I equals this equals that, without necessarily needing a paper to work around it.
Okay. And then also, just to clarify, was each multiple choice question worth 1 mark and then the written was worth 5 marks?
Yeah, the written part is 5 and the multiple choice happens to be 1 for each.
Okay, sounds good. Oh, just one last question. Are the multiple choice questions from the textbook?
Yeah, some of them are from the textbook, but it's not always going to be from the textbook. I might have to reshuffle it here and there. Yeah.
Okay.
Sure.
Thanks.
So I sent you guys a file, which happens to be from Ando Pato. I hope you guys might have come across it. That will be my motivation for the end part of Williamson. I'm not going to use much of Williamson's example, even though I might touch on the graphs and all that, but I will urge you guys to have a look at what I sent for better understanding of what I'm about to do. Yeah, I'll start in 2 minutes. So you guys have the luxury to do whatever you want to do and come back and join me in 2 minutes. And again, the TA is going to come in to take the attendance, so make sure you happen to be around. If not, then your attendance for today will be 0. And there will be 1 point of the 100 marks.
Sounds good.
Yeah, sure.
calc? Where's my calc? Sworn I had a calculator. Could have sworn I owned a calculator. And the book, might be. There it is. Where are the calculators? Oh, who are you, sir? Yes. Oh, man. Oh, that shit's.
Yeah, I'm still around. There's a fire alarm. Hopefully, it will go off soon. Yeah, so you guys should give me an additional 3 minutes. I want to check the fire alarm. Okay. There's a fire alarm, so I'm going to check it out right away. Okay, so I'm back. Let's try and then. Is the sound okay? Are you guys having some difficulty hearing me?
That's fine.
I
It's
think
like-
it's okay.
Okay, then let's quickly go ahead and start with today's discussion. So we are basically done with how the individual makes his substitution and income effect and how that affects the overall outcome. Today's discussion is going to look at the labor supply and the labor demand market. Supply and demand market. And we are going to see where the wage is going to be determined and how that is going to be. So we start by looking at two individuals. start by looking at the household. So remember, the story is that we have two types of agents in this economy. We have the household and we have the firm. The firm is interested in demand for labor, which we call ND, labor demand, while the household is interested in supplying the labor, which we end up calling the labor supply, NS. So I'll start by looking at the labor supply and how that affects the economy. Then I'll look at the labor demand from the firm's perspective. This is going to be a bit difficult in terms of the mathematics of it, but if you pay attention to it, it's much easier. So the household has what we call his decision. Basically, what he has is he's interested in maximizing or optimizing his utility. Remember, his utility basically comes from the fact that he consumes a bundle in terms of maybe food or whatever, and then he takes his leisure. However, he has to maximize this utility subject to his budget constraints. And the budget constraint that we saw happens to be C equals W H minus L plus pi minus B minus C when there is taxes. This is the budget constraint that we are used to. So this should be fine. However, for the sake of simplicity, I might have to change this H. Remember, this H represents the 24 hours you have in a day. I can call it 1. Change everything to 1 unit to make our lives easier. Instead of saying 24 hours, why not say just 1 unit to make it much easier? And this L will be a fraction of the 1. So at the end of the day, we have a simpler budget constraint where the H now represents 1. The L represents a fraction of 1. That is to say your L is now between 0 and 1. So that's the first part of it in terms of the budget constraint. In terms of the net income, I don't want to be writing this over and over again. So for the sake of simplicity, you might want to change the difference between your profit and your taxes to something much more simpler, D, which represents your disposable non-wage income. So this budget constraint now becomes much more simpler to work with, which is C equals W 1 minus L plus D. If you have a question, please let me know. If you
No
have
questions.
Good. So this is my new budget constraint. Now the next thing here is, in terms of the utility can take several forms. Good. The utility can take several forms. It can take 3 different forms. We have what we call a continuous form. This might be in the form of maybe lane or whatever. This is what I'm going to use. That's why I'm trying to move away from Williamson, because his examples are much more restrictive. He uses more of substitutes and complements. And we have what we call the substitute, whether there's a substitution between leisure and consumption, and we have what we call complements, whether they tend to complement each other. So these are 3 different utility forms that you might be faced with when I have a quiz or an exam. But for the sake of today, I would like to tackle the most interesting one, which is a continuous one. With the continuous one, we have a very fine shape to work with. So here, again, just to motivate ourselves again, the household tends to maximize its utility subject to the budget constraint. And he does that by choosing how much to consume and how much to have in terms of leisure. So these two guys here are what we call the endogenous variables. So keep that one in mind. These are the variables that he chooses. So whenever you are solving any question, keep your eye on what he chooses within his bundle, which is C and L. Also keep in mind what the budget constraint needs to be. If you understand this setup, then your life is much easier. I maximize my utility, regardless of the shape of it, subject to how much I have in my pocket. And I choose consumption and leisure to do that. For the case of the firm, they also have more or less like the same setup. They also make decisions as to how much to produce. And this will be their setup. A firm comes out with, a firm is always interested in maximizing something, which we call his profit. But he does that by choosing the amount of labor. So here, instead of ND, we are going to call this guy N, instead of NS, we're going to call him ND because this is his labor demand. So he maximizes his profit, which is basically going to be the amount of output minus how much he pays, which is his total cost for the workers. So this is the cost that he pays for the workers, and this is the output that he produces. So he maximizes this profit subject to nothing, basically this. In terms of the shape of his, how do you call it, output, there are several forms that it will take. It might, just like this, the case of the utility function, but what I'm going to look at here is the continuous form, like the Douglas form. So his output, which is Y, might take a shape of F, K, and N. So before I produce anything, be it an apple or orange or whatever, I need some amount of capital. Maybe I need tractors, and I need some amount of labor on the farm to help me produce. So this is my labor. And at the same time, I need some level of technology to better help me produce much faster, which is my Z. So this becomes the setup of the firm, and the results we get here becomes the ND. The result that we get here becomes the NS. And as we remember from 103 or 101 or 102, the point where your supply equals your demand will determine your wage or your price. So the amount of labor supply, which is NS, and the amount of labor demand, which is ND, in the market would then determine our wage. So this will basically be our setup for today. If you have any question, please let me know before I go into the math.
For the household problem, when you set it up and the maximization equation, you said it gives us C and L. So then where does NS come from?
Good. So remember, if I sleep 5 hours a day and I have 24 hours in a day, then the difference
Right.
how much I work, right?
Sounds good. Yeah.
So that will be where NS will be coming from. So I'll quickly.
We have one more question. Are there any budget constraints in firm maximization problem?
No, it's unconstrained.
Unconstrained?
Yeah, we don't have budget constraint for the firm. The
Okay.
constraint is for the household, right?
Okay.
So those are good questions. So let's quickly start by looking at the household. So I have the household set up. He's trying to maximize, choosing C and L. This is utility function L, subject to his budget constraint, which is basically going to be W C equals W, 1 minus L plus B. For his utility function, I'm going to use lane C plus gamma lane L. This will be his utility function. So he gets satisfaction by consuming. So whenever his consumption increases, his utility increases. He also gets satisfaction by having leisure. So whenever his leisure increases, his consumption increases, his utility increases. And this is budget constraint. Now, to solve for the amount of leisure that he will be willing to have, this is what you need to do. We start by looking at the Lagrangian equation. If this is your first time coming across the Lagrangian, let me know. If this is not your first time, that's fine as well. My assumption is that we've already come across Lagrangian. If that's not true, let me know so I get to know how to slow down. So to solve this problem, we need to set up this Lagrangian equation, which is basically going to be its utility plus lambda, his budget constraint. And what do we know in terms of its utility? We know the functional form that it takes. This is lane of C plus gamma lane of L plus lambda. We already know his budget constraint, which is C minus W, 1 minus L plus B. So this becomes a setup for the household. This is what we need to solve. Again, remember what he chooses. He chooses his C and L. So coming back here to optimize this, we need to find the L, the C. When I differentiate this with regards to C, I have 1 over C. There's no C here, so I skip it. There's a C here. So lambda multiplied by C. When I differentiate by C, it just becomes lambda. That's the first part of it. I do the same thing for the second choice that he makes, which is L. So the L, the small L, which is his leisure. There's no L here, there is L here, so it's going to be gamma divided by small L. Plus, there is no, the only place we have L is here, right? So we have plus lambda, this is just W, plus WL. When I differentiate with L, I have W standing on the sum. Is that okay for everyone? If it's not, please let me know. So I have this guy here equals 0, this guy equals 0. And lastly, I differentiate with respect to the constraint, which is the L, the lambda, which basically gives me the budget constraint right away, which is C minus W, 1 minus L plus D equals 0. Is there anyone with any question at this stage? Ella?
Yes. What is the symbol in front of ln of L in a utility function?
Where is that? Is it here? Here? Here?
I think that's what he's referring to, the gamma, right? Yeah.
Let's go.
Yeah.
So this becomes a setup, right? So again, keep this equation somewhere. Now this equation is basically the same as.
Oh, just quickly, what does gamma represent?
Gamma represents the level of sensitivity on his leisure. More or less like, let's see if it's 1-to-1 to his utility, right? I can at the same time put a parameter here. It's just a parameter.
What's that, sorry?
Parameter. Parameter is
oh no, what did you have? Never mind.
Yeah, sure. Let me know if you guys. Yeah. So these are the 3 equations that we have, and we can further break them down. So I can move this guy to this side, and it becomes negative. I can move this guy to this side, it becomes negative. And this guy still remains there. This is lambda, this is lambda. So I can divide them with W. So I have lambda staying by itself. So this guy is no more there. Now the good news is that this guy is minus lambda, this guy is minus lambda. So minus lambda is the same as minus lambda. But at the same time, minus lambda here is 1 over c, whilst minus lambda here is gamma over W over L. Now this is where you have to pay attention. So from these two equations, we've been able to get this guy here. So I'm going to claim what we have on top to make our lives easier, to get much more space. So I have 1 over c equals gamma over WL. I can make c the subject of the equation, which therefore implies that my c will be the same as gamma WL. So this is my c. So this will represent his consumption. But we need to be careful here. That wouldn't be the final consumption that we have in the economy, because within this equation, there is L, which we don't know as well. So the fact that there is L here means that this is not the final solution for its consumption. The good news here is that we can still use this final equation 3 to further break it down. So with this equation 3, life is much easier. What do I mean by that? Remember, equation 3 says that C minus W 1 minus L equals minus D or whatever, D. But I know what C is, so I can replace C with this C. And remember, C is everything here. So instead of writing C, I'm going to replace it with WL all over gamma minus W 1 minus L equals minus D. And things are becoming easier now for us to see. We need L. So this is the same as WL over gamma minus or plus WL minus W equals minus D. I can move the W to this side. So I have W minus D. I can factorize my L out. So I have L W over gamma plus W equals W minus D. I can move everything to this side. I have this is W over gamma plus W. So this becomes my final solution for my L. So this is my L star. This represents how much I'm willing to have in terms of consumption. And remember, this is a star because I don't have any endogenous variable here. That is to say, I don't have C in this equation, neither do I have L in this equation. So I can afford to put a star here, which implies that this is my final solution as to how much leisure he is supposed to have. Is there anyone with any question?
No questions.
Good. Coming back to your question, Ella, if I know that this is his leisure, then 1 minus his leisure will give me his amount of labor supply star. So everything here, 1 minus it, will then represent his labor supply star. Is that okay with everyone?
Yes, that sounds good.
Good. So this becomes his leisure, and we can understand where his, how do you call it? its labor supply will be coming from. Now, the next question here is, what will then be my consumption star? Life is much easier now because I now know what L star is. When I replace L star with the value here, I now have C star. And you guys will now understand that this here is my L star, so I'll come back and replace it with that. So this is W minus D all over W over gamma plus W. So this now becomes my C star. So we now know his C star and we now know his L star. Is there anyone with any question? If it's not clear as well, please let me know. Anyone in the chat room with any question? Questions?
No questions.
Good.
Oh, wait. Can you repeat that again? And then someone else says, does the gamma stay as a variable in the final answer? The repeating part, that refers to the very last part. I think when you replaced L star in the previous.
Yeah, so when I replaced, so remember here we had L, which was in the star. Now, when you replace L with L star, the first thing we need to ask ourselves is, these two endogenous variables that I pointed out earlier, L and C. Is there any L or C here when we replace L with L star? No. So the fact that there's no L or C means that this becomes my final solution. If I finish solving, I realize that there is a C or L within this equation, then I don't have a star. It means I need to do more work to end up with a better solution. As soon as I replace it, there's no L or C, so that becomes my final solution. This is going to be very important. So you guys should keep that in mind.
Sounds good. And then does gamma stay as a variable in the final answer?
It stays as a parameter. So everything here is really, you don't have control over. The only two things you have control over is L and C, and those are the endogenous variables. Right? So everything here stays as a parameter.
So in a practice question, gamma would likely be given a number, right? Like we'd be given the value or like from the question?
It might or it might not be. So what I will show you guys here is something very simple. So that's a good question. So let me quickly come back here and show you guys what I mean by it. So look, have a look at it. Remember, gamma happens to be in front of your leisure, right? It means it tells you how much you value leisure, right? When gamma goes up, what happens to your consumption? Your consumption comes down. That's the intuition. The intuition here is that the gamma captures how much you value leisure. So when you live in an economy where your valuation of leisure goes up, it means you are going to sleep more, and the more you sleep, the less work that you have to do. And the less work that you have to do, the less food you have to feed yourself. So your consumption comes down. Do we get that?
Okay, yeah.
Yeah. Good. So that's the whole idea behind that point. So if you happen to be in the chat room, you guys should type your full name and type yes, and we'll continue with it. Just type your full name, type yes, and we'll continue with it. Now the next part here is, let's look at how this affects your consumption for leisure. The same idea. So remember what we saw earlier. So your number of labor supply equals 1 minus W minus D all over W 1 over gamma plus 1. So let's see where the income effect and substitution effect also comes in here. Remember, given the wage income, or let's take the non-wage income. So this is pi minus T. This represents your non-wage income. When D increases, this is negative, right? When D goes up, because this is negative and this is negative, D is positive. What happens to your number of labor supply? It goes up. The intuition is not clear. I think we might have to work on it. So that's one thing we have to look at. When these parameters increases, what happens to your consumption of leisure and your consumption of goods? So just keep this one in mind. If you have any question, just let me know and I'll come back and look at it. What I'm trying to do here is to see how this labor supply, NS, changes when D changes. Work this out. Look at how your labor supply changes when your wage changes. If it is greater, then it means substitution effect is higher. If it is less, it means income effect is higher. So if you have any question, let me know. Questions? So let's quickly go to the firms and work around it. So keep the amount of labor supply somewhere fixed. Again, everything I'm doing here should be in the Andopauto. You can have a look at the file I sent this morning. You should have it in there. For the firm, remember the firm also has his profit. His profit comes from, let's use a production function that looks like a Cobb-Douglas. That is to say, whenever he's interested in producing something, he needs capital and he needs amount of labor. He needs to demand some labor, minus the fact that he pays for the labor. Because of Cobb-Douglas production function, you might want to put alpha here and 1 minus alpha here, or you might want to put 1 minus alpha here and alpha there. It doesn't make a difference. Let's try and see how we can solve for the ND here. Basically, what you need to do is you differentiate this guy, the pi, the ND, equate it to 0, and that will give you the maximum amount of labor demand that he needs. So when you do that to this equation, you end up with 1 minus alpha Z K alpha ND minus alpha equals W. So this again will end up giving us what our labor demand is. At this point, when you solve for it, you end up with W divided by 1 minus alpha divided by K, ZK alpha, and that will then give you the amount of your labor demand. But remember, there is still a minus alpha here. For you to get rid of this alpha, multiply everything here by 1 over minus alpha, multiplied by 1 minus alpha. This cancels this. So you end up with your ND star being this. So you have W, 1 minus alpha, Z, K alpha, all into brackets, 1 over 1 minus alpha. So this becomes your ND star, and you already know your NS star as well. And if you are to do the math, that will be the final part of today. If you are to do the math, you only get the final solution of your wage star at the point where the household is supplying the best they can, the firm is demanding the best they can. When this point meets, you have your wage star. And that's what we see on this diagram. at the point where your supply, your labor supply from the household that we just saw will be equal to your labor demand from the firms, and this point here will give you your W star, and that will be the point where the market clears. So that's what I wanted you guys to point out. If you want to do the math is very simple. Pick up this equation, equate it to this equation, and make W the subject of the equation. That will give you your W star. I don't know the time left, but if you guys have any questions, please let me know. Questions?
What's the value on the x-axis of that graph you just made?
Supply or the number of labor demand.
Okay.
That's the amount of hours that you would like to have. The firm will be demanding maybe 10 hours. The household will be supplying 9 hours. That will not give us a final solution. The only point where we have firm willing to supply, household willing to supply 10 hours, and the firm is willing to demand 10 hours, that will be the point where we have the final solution. And that's the reason why we have to equate the labor supply to the labor demand. The labor supply star to the labor demand star. Put this equation here, put the other equation here. The W that comes out of it will be this W. Yeah. Any questions, Ella? Yeah.
How did you calculate the profit part, referring to the differentiation part, and the derivative of profit in terms of N and of demand?
Oh, so for the profit, remember, let me just take you guys back. For the profit of everyone in an economy is basically pi, which is the difference between how much you produce minus how much you paid for in terms of cost. But this guy here is ambiguous. We don't know the nature of how your production process goes. So to make our lives easier, we might want to go with a Cobb-Douglas production function. So let's assume that your production function looks like F Z K to the power alpha N to the power 1 minus alpha. This is to say, for every apple that you are willing to produce, you need to have capital, which is tractors or cutlasses or anything that you need on the farm. In addition to that, you also need number of workers. When you combine these two with these powers, you can get your output out, right? So this is your Y minus how much you pay for in terms of those who are working for you. And that will give you your profits. And when you differentiate this guy, because remember the firm is making a choice on how many workers to choose. So here he's maximizing this guy, choosing the amount of labor supply. So you have to now differentiate it with NS, because that's the choice that you are making. Just like the case of the household, they are making the choice on consumption and leisure. Here the firm is making a choice on how much labor to demand. So when you differentiate this function, there's N here. So you end up with Z, K alpha, when you differentiate this, is 1 minus alpha, N minus 1 alpha. There's N here, it goes away, equate it to 0. And you just make the N the subject of the equation. That should come out. Is that clear? Is that clear? Okay, and again, the alpha is between 0 and 1. Keep that one in mind. It doesn't go past this factors. So the math you guys need to work on is go start everything again from scratch. See whether you can get yourself around getting NS star, ND star, and equate the two together and make the wage the subject of the equation. That will give you the final wage in the economy. If you have any troubles, you can let me know, or you can have a look at the lecture note that I posted on Canvas. Any further questions?
Yeah, we have one last question. Going back to the household section, when D increases, you said people want to work more. Can you explain that?
No, I don't think so. I think there might be, I think I might have missed a sign somewhere. It should be the opposite, because when your net income increases, yeah, it should be the opposite, because when your net income increases, when your net non-wage income increases, the amount of labor supply should go down. Right? So maybe there
Okay.
might be a sign that we missed. So try and then work around it by yourselves and get back to me. Yeah.
Okay, sounds good.
Everything here should be what you need to work on. So this is the whole idea on labor supply and labor demand and how to work it out. So for you to prepare for exams on chapter 4, you don't only need Williamson, you also need the Andolfato chapter on output and employment. Make sure you combine these two to have a fair idea of what they are saying, because I might bring questions from it or from Williamson. We don't know where it will be coming from, but this should be comprehensive enough. If you have any additional questions, let me know. If not, then that will be for today. I might have office hours tomorrow, 1 hour as well. If you have questions, just come in and ask. Okay.
Okay, no more questions.
Sure. See you guys.
Thank you.